Hello learners, welcome to this beautiful session of ours today. I am your instructor, CPA Ringo Frederick. In our class today is a continuation of what you are doing. Recall in our previous class you had introduced the concept of our decision trees. I gave you detailed introduction and foundation of the same. So today I want us to look at a concept of a decision tree where I am dealing with the concept of net present value, because remember we are looking at decision trees in financial management. So it will be very important that we also do understand in situations where I am required basically to prepare decision trees in the event that I am having discounted cash flows, how will we go about it? That is what I want us to learn today. And on that note, I want us to use this question. Literally, you can basically download this question for you to have a view of it as we'll be going through it. It's a very interesting question, quite detailed, and it has a lot of concepts which by the time we are done with this class, you'll find that literally, I'm very sure that there's no question that you can't handle when it comes to decision trees and the concept of NPV. So in our question, we are told that Bora Manufacturers Limited, it tends to purchase processing machine costing 40 million. So that is the cost of this processing machine. I'm also told that the machine is expected to have an economic life of 2 years with a salvage value at the end of its useful life. Okay, to adjust for risk on this investment, probabilities have been attached to the expected cash flows over the 2-year period as shown below. I'm given year 1 and year 2. And in this case, this is the data that I'm given. I'm told that we had, of course, our cash flows, year 1 probability, year 2 probability. Additional information, we are told that the cash flow in year 2 are conditional on cash flow in year 1. So, in this case, whatever that you are going to earn in year 2 will basically be determined with what will be earning in year 1. I'm also told here that the cost of capital is 10%. We are told to ignore depreciation. Then a good examiner here wants us to determine, number 1, a decision tree of the investment project. Number 2, the best possible net present value NPV of the project and its probability of occurrence. The worst possible NPV of the project and its probability of occurrence, expected NPV, and you're also supposed to advise the management of Bora Manufacturers Limited on whether the processing machine should be purchased. So this is a very good question because it has covered a lot of concepts that we need to basically understand. And on this case, I want us to correct something here. You see on the probability for 30 million, 0.6, that is of course year 2, it should be 0.4, 0.3, 0.4, 0.5, and 0.1. The last bit should be 0.1, not 0.3. So let us correct that. Should be 0.4, 0.5, 0.1. I'm talking of cash flow where I'm having 30 million in year 1. The probability is 0.6. You see the payoffs, I'm having 20, 25, 30. So the probability should be 0.4, 0.5, and 0.1. So kindly correct that. Kindly correct that. Should be 0.1. Now, given such a question, my good students, whenever I am dealing with the concepts of NPV, at whichever level that you're dealing with, should it be foundation level, should it be advanced level, so long as it has a concept of NPV, it is important for us to understand that always, whenever I am required to determine our NPV, NPV will always be equal to the present value of cash flows, with less our initial outlay, This is always how we can determine our NPV. Now, where the difference will come in is in regard to the present value of our cash flows. It is in regard to the present value of our cash flows, this concept here. So at this point, we should understand that when you are talking of our present value of our cash flows, my good students, anytime you are talking of our present value of your cash flows, this is what you must always tend to have in mind. present value of cash flows, it will be determined whether the cash flow is regular or irregular. So let us start with a case whereby my present value of cash flows, where I am dealing with basically we can start with basically irregular cash flows. Okay, irregular cash flows. Irregular cash flows, also we can term it as what? As lump sum. So when I am dealing with the concept of irregular cash flows or lump sum, for us to determine our discount factor, this is what we must always tend to have: the present value interest factor given the rate and number of years. This one we are going to determine by taking of course 1 plus r raised to power negative n. That is what we are going, that's how we are going to determine that factor in the event that I'm dealing with irregular cash flows. What if in this scenario, my good students, I am dealing with regular cash flows? We should understand that irregular cash flows, basically, in this case, I'm receiving different sum over the years, right? See, year 1, maybe I'm receiving 20, year 2, I'm receiving 10, like that, meaning that our cash flows tend to vary, okay? What about when I'm having the concept of regular cash flows? When you're talking of regular cash flows, also referred to as annuity, you will find that in this case, I'll determine our discount factor by taking present value interest factor annuity given the rate and number of years. And on this, we should always remember this formula: 1 minus into 1 plus r raised to power negative n, but this time around I'm also going to divide by what? By r. So this is a guiding maybe information that we should always be having at any given point. You are dealing with a concept of NPV. At any given point, always, whenever you're dealing with NPV, always have that in mind. That will really, really help you. Okay? Excuse. So once we have this, we can proceed and look at that question of ours. A good examiner wants us to determine want us to prepare basically our decision tree, a graphical representation of the data that I'm given, as well as the NPVs. So this is what we are going to do. Let us prepare this decision tree, and on doing this, I'm going to have a question here. We can literally squeeze this question so long as it's visible. We have it there. This is our focus. I want us to prepare basically our decision tree. So on decision tree, remember there are two concepts that we must always tend to remember: the concept of decision alternatives and the concept of state of nature. These will be the building blocks in our decision tree. So on that note, decision alternative, what can we choose? What do we have control over? And remember, we mentioned that it's always going to be represented by that decision node, the square figure, right? So this is what I'm having. I'm having basically, we're told like Bora Manufacturers Limited intends to purchase processing machine costing 40 million. So this is to say, my good students, clearly, I'm having Bora, and Bora, they do have this decision of purchasing. So I can, let me squeeze it here. I have this decision of purchasing. Okay? We have a decision of what? We have a decision of purchasing. So on purchasing, in this case, I can either decide to purchase, or on the other hand, actually, we can do what? We can decide not to purchase. So this is decision alternative, purchase. So if we purchase, how much are we going to spend? If you purchase, we've been told we are going to spend 40 million. That is if we purchase, because the project or that machine will cost us what? 40 million as per the question, right? The machine is expected to have an economic life of 2 years with a salvage value of at the end of the useful life. To adjust for risk on the investment, probabilities have been attached to the expected cash flows over the 2 years period as shown below. This is what I'm given, year 1, and I'm having the state of nature. So this is what will happen. If I have purchased this machinery, that is of course the decision of purchasing and not to purchase. These are decision alternative, right? So of course this one I'm going to spend 0. So if we purchase, what will happen? In year 1, I can either generate these values, I can either generate a specific amount, which is 25 million. Look at that case. I'm having 25 million, and the probability of me generating 25 million is 0.4. So I can generate 25 million here. Probability of us generating 25 million is 0.4. Or we can generate 30 million. Probability of us generating 30 million is 0.6. That is what the examiner is telling us. This is year 1. This is year 1. Year 1. This is year 1. That is what you are having up to that point, right? That is what you are having up to this point. And what were we told? In our additional information, my good students, check it out. We are told in note number 1 that the cash flow in year 2 are conditional on cash flows in year 1. So cash flows in year 2 will literally depend on what we've earned in year 1. So what will be the next step here? Check year 1. If year 1 we generated 25 million and that probability was 0.4, what will I generate in year 2? In year 2, we are going to generate the following. That is, I'm going to generate, I can either generate, of course, 12 million. I can either generate 12 million, 16 million, or 22 million. So this is what I'll be having here. So here we are saying we can either generate 12 million. Actually, you can have it here. Let me just have it here as our payoff. I can either generate 12 million, 16 million, or 22 million. With probability being, with probability here, with probability being 0.2, 0.3, and 0.5. That if year 1 we had 25 million. That is if year 1 we had 25 million. The same case, there's a chance that I can also generate this amount in year 2. There's a chance that I can generate this amount in year 2. Still, remember we are in year 2. So basically this is what you have in year 2 here, okay? So year 2, I can also generate this sum. I can as well generate a figure of how much, my good students. We can generate, based on what we are given there, we can generate either 20 million, 25 million, or 30 million. with probabilities of what? With probabilities of 0.4, with probability here of 0.4, 0.5. We say this one should be 0.1. We corrected that should be 0.1. So that is what I should be having. Okay? So in this case, that is to say, at this point, if we don't purchase, what will happen? If we don't purchase, literally, I'm going to spend none. I'm going to spend 0. So in this case, if I don't invest, of course, what will you be having? I'll be having dash there. I won't be having anything. So that is what I'm having, my good student. That is what you're having here. Now, after that, we have basically prepared our decision tree, elaborating and going through it just like that. Go to the next question. Remember, if we didn't have the concept of NPV, we could have literally rolled back to our final decision that we should take. But because I am dealing with the concept of NPV, we must incorporate the NPV first. This is what Mwalimu is saying. That if it was just the other way, I could have rolled back and see the best option that I could have taken based on my investment. But because I'm dealing with NPV, then we must incorporate the NPV. Look at the next question. Examiner is telling us what? In this case, we are told that the best possible net present value of the project and its probability of occurrence. So what will be the next, or rather the best NPV? Therefore, at this point, you must now incorporate the concept of NPV. Recall, NPV Mwalimu had mentioned to us that literally we'll be talking of what? The concept of present values and the concept of what? Initial outlay. So therefore, I need to determine our discount factor. And discount factor will depend with the nature of our cash flows. We can clearly see here that our nature is irregular because year 1, I'm having 25 million. Year 2 was dependent in year 1, and also we had irregular cash flows. So this will bring us to this factor of determining our factor here. Our factor, which should be present value interest factor given the rate a number of years, where we mention that I should be talking of what? 1 plus r raised power negative n. So we start with year 1. What will be your factor in year 1, my good students? Year 1, I'm having 1. Discounting rate is 0.1 because it's 10% raised power negative 1. Year 2, what will you be having in year 2? 1 plus 0.1 raised power negative 2. So that in this case, what will you be having? In this case, what will you be having? I'm going to pick my calculator. Remember that you can also check it on your table. So I'm having here 1.1 raised power negative 1, which this one should give me a figure of 0.9. So I'm getting a figure of 0.9091. The other one I'm getting 1.1 raised power negative 2. This one should give us 0.8264. Kindly, guys, you can confirm if we are getting that. You can confirm if you are getting that. So that on this end, this is now what we are going to do. Remember our NPV when we started? I need to determine the present value of our cash flows. We deduct our initial outlay. Let us jump to year 1 when I was generating 25 million, and year 2 conditional of us generating 25 million. What will we be having? I'm going to start with this first branch of 12 million. So this is what I'll be having. I'll be having, of course, my 25 million here. We multiply by the interest factor year 1, which is 0.9091, okay? We are going to add this branch is 12 million. So 12 by the discounting factor year 2, 0.8264. Okay? So that as at the end of the day, having all this, we are going to less our initial outlay, which was 40 million. So that should give us our NPV of how much? That should give us our NPV of how much, my good students? Pick your calculator. We start working out 25 times 0.9091 plus 12 by 0.8264 minus 40. Mwalimu is getting here, you can confirm, I'm getting negative 7.3557. Kindly you can confirm if you're getting the same. This branch, we go to the other branch. This branch is 16 million. So I'm having 25 by 0.9091. We add, this branch is 16 million by 0.8264 minus 40. 25 by 0.9091 plus 22 by 0.8264, right? Minus 40. So what will we be having here? I should be talking of basically 25 by 0.9091 plus, of course, 16 times 0.8264. In this case, minus 40. This should give us a figure of 4 point. I'm having negative 4.0501. The next bit here, I'm having, of course, 25 times 0.9091. We add 22 by 0.8264 minus 40 here. My good students, I'm getting 0.9083. Kindly you can confirm with what you're getting. So once I'm done with the first branch, we proceed to the second branch of 30 million. So what will we be having here? Now I know it will flow. So let me just remove this. So this branch will give us, now we are at 30 million. Year 1, we had 30 million. So I'm having 30 million here by 0.9091. So because all this will be the same, 30 by 0.9091, 30 by 0.9091. This is where I'm having, where year 1 we generated 30 million, right? Plus now, cash flows year 2, branch 1, I should be having 20 million by 0.8264 minus 40 plus 25 by 0.8264 minus 40 plus 30 by 0.8264 minus 40. Okay? So what will we have, my good students, here? This will give us how much? Let us check it out. The first one should be 30 by 0.9091 plus 20 by 0.8264 minus 40. That should give us 3 point. That should give us basically 3.801. That is what I'm getting. Branch 2, 30 times 0.9091. Okay. We add 25 by 0.8264 minus 40. This should give us 7.9 33. I believe that we are all on the same page. Lastly, I'm having 30 by 0.9091. We add 30 by 0.8264. We less 40. Less 40, that should give us 12.065. So that is what Mwalimu is getting in relation to all our NPV in all our branches. Now, the question here wanted us to do what? The question here, my good students, if you can check clearly, we were told to give what? Part 2 and 3, the best possible NPV of the project and its probability, as well as the worst possible. So we start with the best possible. The best possible NPV, where are we generating the highest NPV in all these three? The event, or rather the point where I'm generating the highest NPV, if you can check clearly, is what? 12.065, right? So literally, this is what I'm going to take as the highest. Literally, this one is what? This one is the highest here, right? What is the probability, the resultant probability of that? In this case, I need to take the joint probabilities. I need to take the joint probability. So the joint probability at this point, I'll be having the 0.6 here, because it is lying in this line, or rather in this branch. So I'll be having 0.6. We multiply by 0.1. So that should give us a resultant probability of what? The probability, therefore, should be 0.6 times 0.1, 0.6 times 0.1. In this case, I'm getting 0.06. So we can agree and say, therefore, that this time round, our resultant probability here is 0.06. Resultant probability of the highest NPV, because you are talking of the joint probability 0.6 and 0.1, as simple as that. What about the worst? The worst possible NPV, literally I can see the first one, negative 7.3557, or you're going to say that Mwalimu 0 point is the worst? Of course you can see it is negative 7, right? So therefore I'm going to take negative 7. This is the worst. This is the worst. What about the resultant probability? The resultant probability, I'm going to take, of course, our 0.4 here times the probability of that branch, which is 0.2. So therefore, I'm going to take 0.4 by 0.2 to give us 0.08. So therefore, my good students, we can agree and say, therefore, that the resultant probability of the worst NPV is 0.08. So that is what you are required to do, actually, number 1 and number 2. Is that okay? Believing that is okay. Let us see the next item. The examiner wanted us to do what? The examiner here wanted us, number 4, to basically work out expected NPV, expected net present value. Anytime, my good students, anytime you see expected, what should come at the back of your mind is the concept of summation of our probabilities times the payoff. And this case now, the good thing is that our payoff, we are going to take it as our NPV. That is a payoff that you're going to take. So therefore, let us do this. We need to determine our expected NPV. Examiner wants us to determine our expected NPV. This will be simple. Mwalimu is saying it's simple because already we have determined our NPVs here. So what we are going to do, we are going to take, we start with year 1. In this case, I'm having year 1 where I was generating 25 million. So I'm starting with this branch. This branch will give us our NPV. The first NPV is negative 7.3557 times our joint probability. Our joint probability is 0.4 times 0.2, which gave us 0.08. We add. The next NPV here is negative 4.0501 times the joint probability. Joint probability will be 0.4 times 0.3, which will give us 0.12, which will give us 0.12. So that this should give us plus the other NPV 0.9083 times the joint probability 0.4 by 0.5, 0.4 by 0.5, this should give us 0.2. So that as at the end of the day, what will we be having here? I'll be having negative 7.3557 times 0.008. We add negative 4.0501 times 0.12. We add 0.9083 by 0.2. This should give us negative 0.8, negative 0.8929. Okay? What about the next item here? We go to the second branch. The second branch, I'm having 3.801 times our joint probability. What will be our joint probability? 0.6 times 0.4. 0.6 times 0.4. This should give us 0.24. We add probability of, or rather payoff of which is NPV 7.933 times probability joint 0.6 times 0.5. This should give us 0.3. Excuse me, add the last one, 12.065 times joint probability 0.06. So this should give us what? This should give us 3.801 times 0.24. We add 7.933 by 0.3. We are going to add 12.065 by 0.06. So that as at the end of the day, this should give us what? 4.6233. So our expected NPV, we sum this one up. So that as at the end of the day, my good students, we should be talking of plus minus 0.8929. So I can clearly see that my NPV here is 3.7304. Expected NPV. Expected NPV. That is what the examiner wanted us to determine. That's what the examiner wanted us to determine. Just like that. What was the next question here? The next question, my good students, we are told what? The next question, of course, is to advise. Advise the management of Bora Manufacturers Limited on whether the processing machine should be purchased. What can we advise? Based with our knowledge of NPV, what do you think? Of course, they should purchase this machine because it has a positive expected net present value. It has a positive expected net present value. Therefore, they should proceed and purchase that machine. Literally, that is what the examiner expected you to do in this question. It is a very good question with actually majority of the concepts that we need to understand anytime you are handling decision tree. Now, let us do this. Let us add our own question there. To sum up the whole concept, actually, we can add our question here and clear this bit at once. What if the examiner here had asked us to compute the standard deviation of this machine? The standard deviation of this machine. That is, of course, how will we have done it? This is what we should do. At this point, my good student, it is important that you recall the concept of standard deviation, where we said that standard deviation, literally, we normally tend to talk of our, let me have this somewhere. Standard deviation, recall, we normally tend to talk of our return minus expected return. We square this one times probability, summation, then we do what? Square root. This is our whole idea of standard deviation, the one that we know, right? But because I'm dealing with NPV, nothing much will change. What we'll be having is just our actual NPV minus expected NPV. Of course, this one squared times our probability, then summation of that. We do what? We determine the square root. Nothing will change. Nothing much will change. This is how we can determine basically our standard deviation. Do you want Mwalimu also to work out this one really? Or you can do it on our own? Mwalimu afanye kazi yake. Okay. Let us see. So, I've determined our expected NPV here, which is 3.7304. That is our expected NPV that we've literally determined. Joint probability, we can redo it again because no need of us writing all this again. So I want us to work it out. So in this case, I'm having our case here. That should be, of course, our actual NPV minus expected NPV. We can start with our first branch. Actual NPV is negative 7.3557. We less our expected NPV 3.7304. We square this one. We multiply it by our joint probability, which was 0.08. We proceed to the next item. I'm having negative 4.0501 minus expected 3.7304. We square this one times our joint probability 0.4 times 0.3, we got 0.12. NPV 0.9083 minus expected 3.7304. We square times joint probability 0.4 times 0.5, which literally gave us what? 0.2. Then we proceed to the next item, which I'm having 3.801 minus 3.7304. This one squared times joint probability 0.6 times 0.4 to give us 0.24. I'm having the next one is 7.933 minus, of course, 3.7304. We square times our joint probability 0.6 times 0.5 to give us 0.3. Then lastly, I'm having 12.065 minus 3.7304. You square times joint probability 0.06, so that as at the end of the day, my good students, determining the summation, whichever answer that you're going to have, you square root. That will give us our standard deviation, and that one Mwalimu will not do for us, will not do it for us. I want you guys to take that chance and work it out on your own. Give me the standard deviation on that. So you'll find that in this case, actually, we are done with that question, and also the concept of decision tree in regard to NPV. There's a question in either August or April 2022. There is a question for decision tree. Remember, like it was not tested the other day, April. It was not tested in December. So check the concept of decision tree either in August or basically that is April 2022. The same concept applies, and that question is almost the same question as what we've done here, which we are going to do that question in the next session. To this point, guys, thank you so much. Let us meet in the next session, whereby we are going to handle another question for decision tree, which is at either August or April 2022. Thank you, and see you then.